Okay, so hello everyone. We're talking in character frequency analysis to determine the root language and proper nouns of the Voynich manuscript. This is just a quick overview of what we're going to talk about today.
So what is the Voynich Manuscript? The Voynich Manuscript is an unknown manuscript with pretty mysterious origins. We believe that the manuscript originated in around the early 15th century, although we're not sure, and the author is also unknown. It's written in Voynichese, as seen on the right, which is a really foreign, unidentified language with unknown character sets. It includes 6 different codex sections, which include the botanical section and the pharmaceutical section. The botanical section, as an example, can be shown on the right with a plant. It has an incomplete archival since several folios or pages are missing from its current archived version at the Beinecke Library. It has been inherited through multiple owners throughout history, including King Rudolf II of Spain and Wilfrid Voynich, which is the namesake of the Voynich manuscript, and it currently resides in the Beinecke Library.
Now we're talking about methodology.
So we use frequency analysis to look for proper nouns. First, we look at the first word on each page in the plant category of the Voynich manuscript. We inserted each first word into a code that gave back how many times the word appeared throughout the manuscript. If the word only showed up one time throughout the manuscript and it was in the plant category, we can conclude that the word is the name of the plant. And the code created by Aditya Virathu, the first print function shows how many times the word appears by itself. The second print function shows how many times the word shows up with prefixes or suffixes. And the third print function displays what sections of the manuscript the word is found in.
So using the third function, we are able to determine the exact number of folios that a word appears in, and we're also able to determine the number of times that the word appears. So let's say that we have a word that appears 2 times in the entire manuscript, but it just appears in one folio. Then, using this, we can conclude that this word is very important to this specific page, and we can attempt to identify the word. So how the code works is you make a set of every word that appears in the manuscript. And then you create a second set which just contains the folios that it appears in, and then you just do a few if statements and put all of the results in a file.
So for our methodology, when it came to determining the root language, we began by creating a list of languages that we thought could be the root language. And these were Latin, Portuguese, Bahasa, Italian, and Galician Portuguese. And we chose these languages since several papers mentioned them as possible root languages. Word Creator had pre-existing frequency data on all these languages other than Galician Portuguese. So the term diagram refers to 2 successive letters, and we decided to look at diagrams since Dr. Cheshire suggested in one of his papers that Voynich is a pronuncial writing system. For Galician Portuguese, we found text that dated to around the 15th century, since that is when carbon dating places the Voynich manuscript. Galician Portuguese is an ancestor of Portuguese and is different enough from Portuguese that it requires its own frequency analysis, and it was mentioned several times in papers. We then put the sample text through Word Creator to determine the character and diagram frequencies.
So in order to find which of the 5 languages could be the root language of Voynichese, we compared their letter frequency distributions to that of Voynichese and saw which was the most similar. So here you can see 2 letter frequency distributions from left to right. We have the most occurring letter in the language to the least occurring letter in the language. So in order to conduct this comparison, we use the Kolmogorov-Smirnov test, or the KS test. This produces a numerical value called the D statistic, which is a measure of the greatest distance between two distributions. So essentially, the language that produced the smallest D statistic or difference from the Voynich language would be our root language.
So now I'll talk about our root language code. So when we conducted the KS test, we had two methods of doing it. The first one is manually through a Google spreadsheets, and the other one is using Python. So for our Python code, we mainly use three libraries, and that was SciPy, Seaborn, and Pandas. SciPy was used to conduct our KS test function. Seaborn was used to graph our data and our results, and Pandas was used to read our CSVs. I'll explain more about that later. So there are three main sections of our code. The first one is formatting the data. So the files that we input into our code have non-numerical values, but in order for our KS test function to work, we need to clean the data a little and make sure that the inputs are in the correct format. So that's what the first section of the code does. The second section of the code is running the KS test and graphing its results. We ran the KS test using SciPy and then graphing results using Seaborn, like I said earlier. And then the third section of our code is formatting CSVs for our spreadsheet. So the way we conducted our spreadsheet KS test is the inputted character frequencies need to be in a certain format in order for the results to be produced. So an easier way for us to do this was to put the data through the code, and what would be outputted were the CSVs that we could copy and paste over to our spreadsheets and for the KS test. So in summary, what would be inputted into our code are two files, character and diagram frequencies of Voynichese and the language it's being compared to. And what would be outputted is the KS test's D statistic, p-value, and the formatted CSVs for our spreadsheets. Results and conclusions.
So after looking at 113 first words in the plant category of the manuscript, we gathered that 75 first words only appeared one time throughout the manuscript. So that was 66.4% of the first words. And since a large amount of first words only appear once and in only the plant category of the manuscript, it can be concluded that these first words that only appear once are the names of the plants.
So for the root language section, based on the KS test, we determined that the language with the smallest D statistic, which refers to the difference from Voynich, was Galician Portuguese. And the bar graph on the bottom shows the D statistics for each of the languages we tested. In the top graph on the right is the frequency distribution for individual characters of both Voynich, which is shown in red, and Galician Portuguese, which is, shown in blue, and Galician Portuguese, which is shown in red. And the line of best fit are included for both. On the bottom is the diagram frequencies for the same languages, and it can be seen that the single character distribution is much more similar to Voynich than the diagram distribution, and this is evidence against each glyph representing two characters.
So in the future, we plan on synthesizing our results to help narrow down the parts of speech of individual tense verb of ran. So based on English's grammar rules, we can narrow down the words that follow the. So we can also apply this to Voynichese, but instead of English's grammar, we would be using Galician Portuguese's grammar. And instead of the hint of I went to the, we would be using the hints of our known proper nouns. So we would see, according to the grammar of Galician Portuguese, what parts of speech can follow proper nouns, which will help narrow down the surrounding words of our proper nouns.
So after noting their name, potential area of origin, and purpose of some of the plants, this information not only supports the Silk Road hypothesis due to the locations of these plants lining up along the Silk Road, but unveils potential purposes for including these plants. In the future, we plan to include a map of all the plants up until folio 50V, and potentially go even further to cover all the plants in the map, as many of these plants have origins close to the Silk Road. In addition, the purposes of these plants can be identified and connected to various parts of the manuscript, as well as serve as an explanation for why certain plants appear in the manuscript.
We would like to thank Professor Downing and ASDRP for supporting our research of the Voynich manuscript, and Stefan Trost Media for allowing us to use their language data. And these are our references. Thank you.